If you talk about damage detection as seen in the above example, there can be of two ways. One is model based, other is model free. In the first case of ANN used, one need to have a computational model, in fact have an accurate finite element model of the sample structure. In our case, it is a railway bridge. The damage detection through this first scenario will have a direct physical interpretation, because you have a detailed numerical model of the bridge. Depending upon the location, nature, size and extent of damage, you can physically interpret what would be the loss or degradation on the deck of the railway bridge. You have that advantage. It will be difficult to develop a high accurate numerical model of a complex structure. If it is simple, one can think about it, but if it is intricate, it is very difficult to even develop a numerical model of the structure. If you look at the second case, the second case actually deals with a model free approach. By means of artificial intelligence, the damage is classified and identified as well, and I should say tried to relate to the physical characteristics of the bridge, the model free approach training an algorithm on some sample acquired data, not on the numerical model, but on some other acquired data similar to this. Usually it is done in an unsupervised manner. So, the advantage in this case is, without a detailed numerical model, using artificial intelligence, damage is identified and correlated to physical characteristics based on the algorithm of sample data. In artificial neural network, one of the vital issue is placement of sensors. So, one need to actually look for an optimal sensor placement, because that is deciding feature of successful damage detection, is it not? That is very important, it is a crucial part. People generally use genetic algorithms to choose the sensor type and their location. Lee et al. Recommended dual structure coding and mutation particle swarm optimization. That is DSCMPSO algorithm. Now, in this case the convergence speed of the algorithm highly improved, optimal location is also highly improved as stated by Y et al. In the paper. The next challenge of using ANN in SHM could be separation of changes in structural characteristics, that are caused by vibration induced damage and changes in operational and environmental conditions. So, the solution for this problem could be as accepted by Jean et al. One can use Kalmar filter which can be applied to the network for damage detection, essentially caused by temperature changes, which is one of the environmental condition that causes or induces additional damage other than those induced by vibration on the bridge. So, in this process or in this method, the Kalmar filter is used to estimate the weights of the neural network and the confidence intervals of the natural frequencies which are used for damage detection. The other advantage where ANN can be successfully used in SHM is dependent on the machine learning algorithms. Because ANN has to use certain level decisions at the sensor initiation or at the sensor level to process the data to make it intelligent. So, one need to understand the machine learning algorithms effectiveness on the neural network when they are deployed in health monitoring systems. Generally, the machine learning algorithms are implemented to detect structural abnormalities caused from the monitoring data. Outlier principle to detect these abnormalities. It is based on the training data which is exclusive to the problem being solved. From Case Mosley, Cosmas Dragos and Jens Wiggenbroek, 2016. Machine learning algorithms, proceedings of the 8th European workshop on SHM, 5 to 8 July, Spain. So, the artificial neural network actually uses data driven approaches for decision making. They are successful in civil engineering structures because of the following reasons. You have large quantity of sensor data available for civil engineering structures. Two, the physical characteristics of the structure are complex to model. Thirdly, the computational efforts of ANN need to be reduced in such situation. The option used by researchers were decentralized artificial neural network. So, decentralized ANN follows an embedded machine learning approach to perform the autonomous detection of sensor failures. Or let us say the sensor fault. Therefore, friends, data analysis in structural health monitoring is related to transforming the useful, compact sensor data into useful information, probably in the knowledge format. What do you understand by knowledge format? I should relate this to the physical characteristics of failure. Okay. What are the physical characteristics which we are interested in? One can look for life cycle prediction, one can look for life cycle management, etc. So, we have two approaches, one is what we call data driven, the other can be physics based. Both can be used in ANN as applied to structural health monitoring systems. The physics based approach establish the principal models, then map the physical characteristics, and then compare the output of the physical model with the physical characteristics and then decide damage. Whereas, the data driven approach is similar to unsupervised, untrained data system, which is of course computationally intensive, so the data driven approach depends on comparison of observed data with the previously collected sensor data and then decide the damage scenario. Data driven approach are useful when large sensor data are available. Physical characteristics of the structural model is known. 3. There is a demand of reduction in computational effort. So, friends, in this lecture we discussed about application of artificial neural network in SHM system. We have seen how artificial intelligence can be integrated with artificial neural network to make SHM easy, simple, cost effective, less computational, and so on. With this we end up with the lectures on module 3, where we discussed about sensor technologies, sensor applications, types of sensors, and some application problems related to offshore structures, bridges, etc., laminates, etc. I hope the condensed form of all the set of lectures in module 1, 2 and 3 would have given you an exposure about structural health monitoring as a whole, from its start to a decent level of understanding and applications. In the fourth module, we are going to discuss about a lab scale application on SHM, which we did on a research basis, at IIT Madras in the Department of Ocean Engineering, which I will present the results and discuss the anomalies which has been obtained by using wired and wireless sensor networking, where we will also discuss about the layout, design, implementation difficulties and limitations of wireless sensor networking for various applications in general and very specifically to offshore structures on a lab scale model. Thank you very much. See you in the fourth set of module lectures